Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Today, inshallah, we are going to study the new lesson of triangles, and we will see how to differentiate between different types of triangles. So first of all, the word triangles, the word triangle itself, if we just analyze this word, if we split this word into two syllables, we will find that the first part of this word means three. The word tri means three. So that's why it's called triangle, because it includes three sides and three angles, as we will see now. So we have three sides and three angles. Now, how to read any triangle? If we have triangle ABC, we say that the triangle ABC. And then how to read the sides, we say, and how to read the angles. We say the side AB, the side BC, and the side CA. And as for the angles, we say measurement of angle A. And by the way, the symbol for the angle can be written above the letter as follows, or it can be also written to the left. So measurement of angle A. Also, we can read the angle A by a different way, saying that measurement of angle BAC, putting A in between B and C, exactly in the middle. Measurement of angle B, or measurement of angle ABC. Also, it can be CBA. We can read it from left or from right, but what's most important is that B should be in the middle. Measurement of angle C, or measurement of angle ACB. As long as we said that we have three sides and three angles, so this means that we also have three types of triangles according to the sides and according to the angles. So we have to differentiate between those two types. So first we will discuss the types of the triangles according to the sides. So if we have three sides, they are all equal to each other as follows, and we want to form these the triangle from these sides. So all sides here are equal. So in this case, we say that this triangle is equilateral triangle, and we put three dashes like this as follows, in order to refer that those three sides are all equal. The second assumption we might have is that if we have two sides only are equal, and the third one is different from them. So let's use these sides in order to draw our triangle. So in this case, we have only two sides equal. We put dashes like this in order to refer that they are only two sides are equal. In this case, we call this triangle isosceles triangle. The third type is that in case we have the three sides are different, so none of the sides are equal to each other. None of the sides are equal, so they are all different, so we call it scalene triangle. So now we have three types of the triangle according to the sides. The first is that when we have all sides equal, we call it equilateral. The second is that when we have two sides only are equal, we call it isosceles. And the third is that when we have all sides different, so we call it scalene triangle. So here all equal, here two only equal, here all are different. Let's now discuss the types of the triangles according to the angles. So we have three angles exactly as we have three sides. First of all, we would like to remember something very important, that the measure of the straight angle is measured to be 180, and the measure of the right angle is 90, and we have also what's called the acute angle, which is less than 90, and we have another angle which is obtuse, which is greater than 90. Those are all cases of angles we might have. Of course, we are not going to talk now about the straight angle, because we want to form a triangle. So if we just imagine that these three types below, the acute, the right, the obtuse, if we just connect the third line of the triangle, so we will have acute angle, right angle, and obtuse. So also the types will be right angle triangle, acute angle triangle, and obtuse angle triangle. According to which angle, we will decide which type of this triangle according to the greatest angle. So we will find the greatest angle first, and then decide compare this greatest angle with the 90 degree. If it's less than 90, it will be acute. Equals to 90 will be right. Greater than 90, it will be obtuse. So assuming here that this angle is measured to be 115, so this is greater than, and this is the greatest angle, it will be greater than 90, so I will say that this triangle is obtuse angle triangle. Assuming here also that this angle measured to be 55, so this here, the greatest angle is less than 90, so I will say that this triangle is acute angle triangle. So let's summarize here the types of the triangles according to the angles. We have, if the greatest angle is less than 90, it will be acute angle triangle. If the greatest angle is equal to 90, it will be right angle triangle. If it's greater than 90, the greatest angle, so that we can say the type of this triangle is obtuse angled triangle. So in any of these triangles, we have how many acute angles? We will find that we have at least 2 acute angles. In case of the first one, we have all 3 are acute, and the other 2 cases we have at least 2. So we can have 2 or more acute angle triangles in any triangle, in just one triangle. So from this we can say any triangle has at least 2 acute angles. Referring to the straight angle we discussed before, we will use this property here in a very important thing to prove something. We want to know the sum of the interior angles in any triangle equals what? By the way, the word interior, it means inside, the inside angles or the inner angles or the angles inside this triangle. I want to know their sum measured to be what? So first I will use the straight line, and I know that the measure of the straight angle equals 180. I will use these angles of this triangle, and I want to test them. So I will cut these angles and put them on the straight line. So here I found that they measure to be 180. So this means if I add all these angles to each other, I will have the measure of 180. So the sum of the angle of the interior angles of this triangle is 180. So let's check any other type of the triangle to see if this applies for all triangles or not. So we have here, this is a right angle triangle. We will also cut its angles and put them together. We will also find that they complete each other, so and form 180 degree. So also the sum of the interior angles of this triangle equals 180. Let's check another one. We put it on the straight line. They also measure to be 180. So from this we conclude that the sum of the interior angles of any triangle equals 180. So this is a very important question, and we will use this in many other examples. As we said before, there can be, in any triangle, we can have at least 2 acute angles. What about the right and obtuse? Let's now check. Can we have 2 right angles in one triangle? Let's see. So we will draw the first right angle and the second right angle. And we'll ask ourselves, can this shape be a triangle or not? Of course not. So from this we conclude that we cannot find 2 right angles in one triangle. Let's check the obtuse case. Can we have 2 obtuse angles in one triangle? So we will draw the first obtuse, the second obtuse. So this shape cannot be a triangle. So we can't find 2 obtuse angles in one triangle. But for the acute, as we said before, we can have any triangle includes at least 2 acute angles. Here is a very important property relationship between angles and sides. Actually, angles affect the sides, and sides also affect or reflect the angles. There is a relationship between the angles and sides, and this is something very important we have to know because this helps us a lot in solving the problems. So if we have the angles, we know that the angles affecting the sides. So how this applies? So if angles are equal, Actually, the sides will be equal. And when sides are equal, we basically know that when sides are equal, this triangle will be equilateral triangle. So what about if I have two angles equal? So that two sides will be equal. And when two sides are equal, what's the type of that triangle? Of course, isosceles triangle. Let's see the case of when we have all angles different. So yes, also the sides will be different. And when sides are different, what's the type of that triangle according to the sides? The type is scalene triangle. Actually, also if sides can be referring also to the angles. So if you see all sides equal, you can know that basically, of course, the angles will be equal. Okay, because if angles equal, sides equal. Also, if sides equal, this give you indication that angles also equal. And also, if we have two sides equal, the angles also, we have also two angles equal, and so on. If also sides different, angles will be different. So if I have here equilateral triangle where all sides are equal, what do you expect according to the angles? You're expecting the angles would be different? You're expecting the angles, two angles are equal only? Or what do you expect about this? Of course, based on the previous property we mentioned, that when all sides are equal, angles equal, or when all angles equal, sides are equal. So also here I have sides equal, so of course the angles or all are equal to each other. And this is very important to know this. So in case of the equilateral triangle, now I want to detect what's the measure of the angles of the equilateral triangle. And I know also basically that the sum of the interior angles of any triangle equals 180. So I know that their sum is 180. And they are all equal. So what is the measure of each and every angle of them? If you went to the supermarket to buy a chocolate, and each price of 3 chocolates, and those 3 chocolates, the price of each of them, you want to know the price of each of these chocolates, and you know that their sum is 180, and they are all of the same size. So can you expect, or can you measure, or can you calculate the measure of the price of them? Here also the same case. I know the sum of the angles, and I want to know the measure of each angle. And I know that they are all equal. So I will divide 180 divided the 3 angles to get the measure of the one angle. So the measure of each angle of the equilateral triangle is 60 degrees. Now, what's the greatest angle here? The greatest angle, they are all equal, so you can pick any one of them. It will be 60. Let's compare this 60 with the 90. So this angle is acute or obtuse or right. Of course, it's acute angle triangle. So from this we can know that the equilateral triangle is an acute angled triangle in which each angle equals to 60 degrees. Now the question is, can equilateral triangle be isosceles? If I have an equilateral triangle as follows, I know that basically all sides of the equilateral are equal to each other. Okay, 3 sides here are equal. And in the isosceles, I know that 2 sides are equal. So let's see first the equilateral. Can equilateral be isosceles? If I look to the equilateral triangle, I will find 3 sides equal, and also I can notice that any 2 sides will be equal. So I can pick 2 sides and say that this would be also considered to be isosceles. So equilateral triangle can be considered or can be isosceles. But if I look to the pink triangle, can this triangle be equilateral? In equilateral, I should have all sides equal. So here I have the third side equals to 3 centimeters, which is not equal to 5 to the other 2 sides. So can this be equilateral triangle? Of course not. So any equilateral triangle can be isosceles, but not vice versa. So any isosceles cannot be equilateral. So let's summarize what we discussed now. The types of the triangle according to the sides. If all sides are equal, it will be equilateral. If 2 sides only are equal, it will be isosceles. If none of the sides, if all sides are equal, if none of the sides are equal means that all sides are different, so it will be scalene. according to the angles, we will first pick the greatest angle. If the greatest angle is less than 90, it will be acute angle triangle. If it's equals to 90, it will be right angle triangle. If it's greater than 90, it will be obtuse angle triangle. So let's revise the notes we just discussed. The sum of the measures of the interior angles of any triangle equals 180. Any triangle has at least 2 acute angles. What about the right and obtuse? We can't find 2 right angles in one triangle, and we can't also find 2 obtuse angles in one triangle. The equilateral triangle is an isosceles triangle, can be isosceles triangle, but the isosceles triangle cannot be an equilateral triangle. The equilateral triangle is an acute angled triangle in which each angle equals 60 degrees. Let's now practice. Determine the type of each triangle according to the measure of its angles. So now we will focus on the types according to angles, either acute, right, or obtuse. So the triangle ABC, first we will read A. Triangle ABC, the measurement of angle A equals measurement of angle B equals 45. So how many angles here do we have equal? A and B equals 45, each of them. And then the angle C is a right angle. Okay, as long as he told me that C is a right angle, and this is the greatest one, by the way, because the other two are 45, so it equals to the 90 degree. The right angle means that equals to 90 degrees. So this triangle is right angled triangle. And of course, as we said before, we can't have 2 right angles in one triangle. This also gives you indication. The second one is that triangle MNO, the measurement of angle M equals 60, the measurement of angle N equals 70. Can I determine the type of the triangle without knowing the third angle? So I should bring the third angle first, which is measurement of angle O. And I say that equals 180 minus 60 minus 70 equals 50. And then I will pick the greatest angle out of them. So the greatest is 70, which is less than 90. I compare it with the 90 degree. So it's acute angle triangle. The triangle POR, the measurement of angle P equals 130 degrees, and the measurement of angle O equal 20. I also here don't have the third angle, so I should bring the third angle first before deciding the type of the triangle. So measurement of angle R equals 180 minus 130 minus 20 equals 30 degrees. What's the greatest angle here? The greatest is 130. I will compare it to the 90, so it's greater than 90 degrees, so it's obtuse angled triangle. Determine the type of the triangle according to the measures of its side length. So now my mind should be thinking to the types according to sides, either equilateral, all sides equal, isosceles, 2 sides equal, scalene, all sides different. So let's see the sides. NO, the side NO equals 3 centimeter. Okay, one here might ask why we did not write the line segment above the NO, because when we write equal sign, we don't write the line segment. We don't have to write the line segment. So we say NO equals 3 centimeter, OR 3 centimeter, and RN equals 3 centimeter. So all sides here are equal, so it's equilateral triangle. The second question, AB equals BC equals 9 centimeter. So this means that AB is 9 centimeter and BC also 9 centimeter. So the third side, is it equal to them? No, it's 10, which is CA. So how many sides equal? We have 2 sides equal, so this type is isosceles triangle. This triangle is an isosceles triangle. Then RL equals 7 centimeter, LO equals 5 centimeter, OR equals 6 centimeter. So all sides are different. So here it's scalene triangle. Thanks for watching and jazakumullah khairan. Assalamu alaikum wa rahmatullahi wa barakatuh.